Hello, my name is Cassi Lochhaas. I'm a postdoc at Space Telescope Science Institute in the FOGGIE group, and today I want to tell you about my most recent paper, FOGGIE 5, The Virial Temperature Does Not Describe Gas in a Virialized Galaxy Halo. What we're looking at here on the right is a temperature slice through a simulated circumgalactic medium, and it's this type of view that can tell us a little bit about the main components of the CGM. We have a galaxy disk at the very center of the halo, and then the CGM itself is broken up into a few different components, such as inflowing filaments that are cold and radially extended throughout the halo, outflowing gas, which is hot, coming out from the central galaxy disk, and the halo gas, which is warm and diffuse and fills the rest of the volume of the CGM. And in particular, I want to focus on this halo gas today, because most models tend to assume that the halo gas is at the virial temperature of the galaxy halo. But what we're interested in this paper is whether or not this is actually the case. So in order to explore this, we use the Figuring Out Gas and Galaxies in Enzo, or FOGGIE, simulations. These are cosmological zoom-in simulations run with the AMR code Enzo, where most of the resolution is placed in the circumgalactic medium where the diffuse halo gas lives, within about 200 co-moving kiloparsecs from the central galaxy. The cells in this region can get down to 274 co-moving parsecs in size and tend to be smaller wherever the cooling time of the gas is very short. The galaxies are chosen to be roughly Milky Way-like at redshift 0 and to have no major mergers below redshift 2. So if we look at the temperature of the gas in the halo as a function of radius, where the galaxy disk is at 0, and extending out to the virial radius of the halo, we see there's a general declining trend with temperature. But if we overplot the standard virial temperature on this plot, we see that the outer part of the CGM, which is most expected to be in line with the virial temperature set by cosmological accretion, is in fact not very close to the virial temperature at all. It's about a factor of 2 colder. So in order to understand why this may be the case, let's look at the derivation of the virial temperature. It comes from the virial equation that relates the potential energy and kinetic energy of the gas in the halo, where usually the kinetic energy is assumed to be entirely due to thermal gas motions and nothing else, TH for thermal. The thermal kinetic energy relates only to the temperature, and the potential energy comes from the virial mass and radius of the dark matter halo. So plugging these in and solving for the virial temperature, we end up with a temperature that depends only on the virial mass and radius of the dark matter halo. But as we just saw, this is not a very descriptive temperature for the outer regions of the circumgalactic medium in the FOGGIE simulations. So instead, let's look at a modified virial temperature. We come back to our virial equation again, which is exactly the same as before. But now let's assume that the kinetic energy is the sum of thermal and non-thermal motions. So again, the thermal kinetic energy is the same as before, depending only on temperature. Potential energy is the same as before. But now if we derive our modified virial temperature, it depends on the standard virial temperature as before, but also a non-thermal kinetic energy term, which we can estimate from gas velocities within the halo. So if we look at our plot of temperature versus radius again, we can see that the modified virial temperature does a much better job of describing the temperature of the bulk of the mass of the gas of the halo, much better than the standard virial temperature does. So it would appear as though the halo gas is not actually described by the virial temperature, but rather by a modified virial temperature that includes the contribution of non-thermal gas motions to the energy budget of the halo. And yes, we did actually check that the halo is virialized at this point. So take a look at the paper if you are interested in this and a few other results that are related. The paper is now available on AstroPH, and the link is in the comments below. Thanks for watching.